Hi everyone, I'm Kai Ming. We are from Group 29. Today we are going to talk about heart disease dataset analysis and visualization. Let's begin with introduction. Heart disease is a significant global health issue and one of the leading causes of mortality worldwide. This highlights the urgent need to analyze and address its risk factors. By exploring trends across diverse metrics and demographics, this analysis provides actionable insights aligned with Sustainable Goal 3, which is good health and well-being. This goal focuses on reducing premature mortality from non-communicable disease through effective monitoring and prevention strategies. The primary objective of this analysis is to identify key trends and correlations between factors like serum cholesterol levels, heart rate, and age. Now, let's dive deeper into the demographic analysis of heart disease dataset. The demographic data of the heart disease dataset provides an overview of the sample distribution across age groups and gender. The histogram shows that much of the dataset is concentrated in middle age to older age groups. The 56 to 65 age bracket has the highest representation, with 408 individuals, which is about 39.8%, followed by the 46 to 55 age bracket with 293 individuals, which is 28.59%. The 66 to 75 age group accounts for 105 individuals, 10.24%, while the younger brackets, 36 to 45 and 26 to 35, contain 188 and 25 individuals, which are 18.34% and 2.44% respectively. The 76 to 85 age bracket has the lowest representation with 6 individuals, which is only 0.59%. Dividing the data into these age ranges helps identify key age groups more likely to be affected by heart disease, with a noticeable concentration in middle age and older population. Next, moving on to the pie chart. The gender distribution is represented in the pie chart, revealing that males dominate the dataset, comprising 713 samples, which is 69.56%, while females make up 312 samples, which is 30.44%. This imbalance reflects broader trends in cardiovascular studies, where men are more often affected by heart disease. By organizing the demographic data into age groups and analyzing gender proportions, this section provides critical context for understanding patterns and risk factors in the dataset. This demographic analysis lays the groundwork for investigating other key variables like cholesterol and blood pressure. That's all for me. Thank you.
The third chart is the scatter plot chart. Reason of using scatter plot is because it is ideal for examining relationship between two continuous variables, which is age is the x-axis and the average serum cholesterol is the y-axis. It allows for easy identification of trends such as whether cholesterol levels increases or decrease with age and helps assess the strength and nature of relationship between these variables. For the first is overall trends, positive correlation. As age increases, average cholesterol also rises. So now moving on is breaking down by age group. For the first one is young adults, which is 26 years old until 35 years, average 205.2 mg/dl. Serum cholesterol levels are relatively low in this group, reflecting the general good health and metabolic efficiency of younger individuals. Moving on is early middle age, which is between 36 years old until 45 years, averaging 230.64 mg/dl. A noticeable increase in cholesterol levels occurs as individuals enter middle age. This period of a mass transition where lifestyle factors such as habits, stress, lifestyle occurs. So moving on is peak midlife, which is 46 until 55 years old, averaging 245.58 mg/dl. Cholesterol levels peak significantly in this group. This is a critical stage where risks often emerge for cardiovascular disease such as hypertension, diabetes, and hypercholesterolemia. Moving on is older adults between 56 until 65 years, averaging 253.54 mg/dl. Cholesterol levels continues to rise but at a slower rate. Metabolic showing is aging reduces the body's ability to process cholesterol efficiency. So next is senior adults, which is 66 until 75 years, averaging 254.8 mg/dl. Cholesterol levels plateau at this stage, suggesting that the biological aging process has a more consistent influence on cholesterol levels than lifestyle. Last is elderly, between 76 until 85 years, averaging 250.5 mg/dl. Cholesterol levels decline slightly, potentially reflecting survivorship bias, where individuals with better cardiovascular health or proactive care are all represented in the older age group. Moving on is chart 4, which is line chart. Well, reason for using a line chart is this is good to depict the trend of average maximum heart rate across age range. This type of visualization is ideal for showing continuous data changes over sequential categories, in this case age ranges. A line chart makes it easier to observe patterns such as increase, decrease, and plateaus, and identify key inflection points or trends. Well, overall trend, heart rate declines steadily and with age, reflecting natural cardiovascular aging. Breakdown by age group. Well, for the first one is 26 years old until 35 years. This is the highest rate with 172.72. Younger adults have the highest average maximum heart rate. Next is the age group is 36 years old until 45 years, which is 162.6 ppm, where there is a noticeable decline in the heart rate compared to the youngest age range, reflecting early age-related changes. Moving on is 46 years old until 55 years old, which is 150.57. Decline continues steadily as age increases. Next is 56 years old until 65 years old with 144.51. The heart rate continues to drop, though at a slower rate. Next is 66 until 75 years old age group, which have a 134.72 ppm. The lowest average maximum heart rate is observed in this age group, following the natural aging process. The last one is 76 and 85 years old age group, which have a 139 heart rate. A slight rebound in the maximum heart rate is observed, potentially due to a smaller sample size or survivorship effects.
Hi, my name is Wei Hao Tan. This group bar chart illustrates the average serum cholesterol levels over milligrams per deciliter and average maximum heart rate achieved beats per minute across age brackets, enabling a clear comparison of the trends. The visualization effectively highlights a negative relationship between two variables as age increases, with only minor exceptions. Certain key observations are, for example, the first observations outline the serum cholesterol, where there is a steady increase in the average serum cholesterol levels with age, peaking in the 66 to 75 age bracket, which is around 254.8 milligrams per deciliter, before slightly declining in the 76 to 85 age bracket, which is around 250.5 milligrams over the deciliter. The second observation outlines the maximum heart rate, when there is an average maximum heart rate decreases consistently across age groups, with the lowest value observed in the 66 to 75 bracket, which is around 34.72 beats per minute. There are also some exceptions to the trend. For example, the 76 to 85 age bracket shows a slight decline in the cholesterol, which is around 250.5 milligrams over deciliter, paired with a marginal recovery in the maximum heart rate, which is around 139 beats per minute. Certain negative relationships can also be seen through the graph. For example, in the most age brackets, higher cholesterol levels coincide with lower maximum heart rates. For example, 66 to 75 age bracket exhibits the highest cholesterol level, which is over around 254.8 milligrams per deciliter, and the lowest heart rate, which is around 134.72 beats per minute. This trend is consistent with psychological changes that occurs as individual age. Certain possible reasons for negative relationships can be seen through, for example, cardiovascular efficiency, which with aging, reduced arterial elasticity and heart muscle strength lowers the ability of the heart to reach a high maximum rate, while inefficient lipid metabolism contributes to cholesterol accumulation. Another reason for this could also be lifestyle factors, such as, for example, older individuals may experience compounded effects of prolonged exposure to unhealthy diets or sedentary behaviors. Move on to the graph 6, where it is a comparison of heart disease prevalence across age groups that has been visualized using a bar chart, where each column represents the proportion of individuals with heart disease target equals to 1 within a specific age group. The proportions were calculated by dividing the number of individuals diagnosed with heart disease in each age group by the total sample size of that age group. Use of proportion? Well, the use of proportion was crucial in this analysis because each age group has a different sample size. Using a raw number instead of proportions would lead to a biased visualization, as age group with larger sample sizes, for example, 56 to 65, would dominate the chart, obscuring meaningful trends. Proportions allow for fair comparison across age groups, ensuring that each group's contribution to the data is represented accurately. And also, why do we use bar charts? By using a bar chart, it can directly visualize the proportion of heart disease cases, making it easier to interpret and compare across age groups without aggregating data. Some of the key insights and interpretations for this graph is the youngest age group, which is around 26 to 35 and 36 to 45, exhibits the largest proportions of the heart disease cases at 72% and 73.4% respectively. In the middle age group, which is around 64 to 55 age, the proportion declines to 58.7% and it reaches its lowest in the 56 to 65 age group at 35.05%. Interestingly, the older age group, which is around 66 to 75 and 76 to 85, sees a rise in proportions, again with around 49.52% and 50% respectively. Some of the scientific explanations of this pattern observed in the proportion can be explained by, for example, higher proportions in younger age groups. Small sample sizes in the 26 to 35 age group and 36 to 45 age brackets may inflate the proportion of heart disease cases. It also a drop in the middle age, which is around the 56 to 65 age bracket, can also be another reason. For example, the significant decline in the proportion for this group could indicate the effectiveness of early interventions or healthier lifestyle among aged individuals. Another reason could also be a rise in older age groups, which is around the 66 to 85 age group. The increase in heart disease prevalence aligns with natural aging processes, as cardiovascular risk factors accumulate and lead to higher susceptible in older adults. In conclusion, this study provides a detailed analysis of the relationship between age, serum cholesterol levels, maximum heart rate, and heart disease prevalence. The result reveals that cardiovascular heart health metrics, such as cholesterol levels and heart rate, changes significantly with age, highlighting the importance of monitoring these factors. The analysis also emphasizes how age-specific trends can inform better prevention and management strategies for heart disease. By understanding these relationships, this study aligns with the SDG goal, third one, where good health and well-being, emphasizing the need for improved health monitoring, early detection, and targeted interventions to reduce the burden of heart disease. Here are group member contribution tables, and thank you for listening.